Problems on sound waves. Problem 1. Calculate the wavelength of a sound wave whose frequency is 220 Hz and speed is 440 meter per second in a given medium. So we are given the frequency and the speed of the wave and we need to find the wavelength. So we will just use the wave equation for this. So given parameters are, so wavelength of the sound wave lambda is equal to question mark. We need to find that. And what is given for finding these two? The frequency of a sound wave f, which is given as 220 Hz, and the speed or velocity of the sound wave, which is v, which is equal to 440 meter per second. Now we know the wave equation, and the wave equation states that v is equal to f into lambda. That is, velocity is product of frequency and wavelength. So v here is 440 and f is 220 into lambda. So lambda is 440 by 220, 0 cancels, 22 ones, 22 twos, which is 2 meter. So the wavelength of this sound wave in a given medium, lambda, is equal to 2 meter. Let's see problem 2. A person is listening to a tone of 500 Hz sitting at a distance of 450 meters from the source of the sound. What is the time interval between successive compressions from the source? Remember that sometimes in the problems, some extra information is there which may not be required when we find the solution. So in this case, let's say what is given is frequency of the wave and the distance from the source of the sound. The person is listening at a distance of 450 meters. Does that distance have anything to do with the time interval between successive compressions from the source? It doesn't. Because the time interval between successive compressions from the source is nothing but the time period, which totally depends on the frequency. So the given parameter here is the frequency of the sound wave, which is f is 500 Hz. We know the time interval between successive compressions is, if you draw a wave, successive compressions, this is one compression, this is another compression, this thing is lambda, and also for one complete wave, the time that takes is t, the time period. So the time interval between successive compressions t is equal to 1 by f. We know the relation between the frequency and time period. Hence t becomes 1 by 500, which is 0.002 seconds, which can be written as 2 milliseconds. So the time period in this case is 2 milliseconds. Problem 3. A sound wave has a frequency of 2 kHz and wavelength 35 cm. How long will it take to travel 1.5 km? So what's given is frequency of the wave and wavelength, and we need to find the time period and the velocity. Once we know the velocity, we can find how much time it takes for 1.5 km. So let's see what are the given parameters. The frequency of the sound wave is given, which is represented as f, 2 kilohertz, and this needs to be in terms of hertz to apply the wave equation. So this becomes 2 into 1000 hertz, which is nothing but 2000 hertz. And we also have the wavelength, which is represented as lambda, which is given as 35 centimeter, whereas we need to convert it into meters because wavelength SI unit is meter. So 35 by 100 meters, which is nothing but 0.35 meter. Now apply a wave equation, and wave equation states that V is equal to F into lambda. So V is the velocity of the wave. So we know the F, 2000 hertz, and lambda is 0.35 meters. On multiplication, we get this as 700 meters per second. Now the basic definition of velocity, V is distance travelled by time taken. Now the distance travelled here is 1.5 kilometers. 1.5 into 1000. So we convert it into meters. And the time taken is t, which we do not know, we need to calculate. And we know what is velocity. So 1.5 into 1000 divided by t is equal to, the velocity is 700 meters per second. So therefore t is equal to 1.5 into 1000 divided by 700. 15 by 7, which is 2.14 second. Therefore, we can say that it takes 2.14 seconds for the sound wave to travel 1.5 kilometer. Problem 4. A source is producing 1500 sound waves in 3 seconds. If the distance covered by compression and an adjacent rarefaction be 68 centimeter, find A, frequency, B, wavelength, C, velocity of the sound wave. So this is a typical problem wherein the answers are already given, but we need to understand the question to bring out the answers. So let's see how it is given. Now let's take A. We need to find the frequency. What he said for finding the frequency, the given things are, a source is producing 1500 sound waves. So number of sound waves produced in 3 seconds is 1500. Now we know the frequency is defined as number of sound waves in 1 second. So number of sound waves in 1 second is called frequency, which is nothing but from the above information 1500 by 3. So on cancellation we get 500. So it is 500 hertz. Since frequency is in hertz, so F is equal to 500 hertz. Now let's see B. Wavelength. Now in the question itself the wavelength is given. He says if the distance covered by compression and an adjacent rarefaction be 68 centimeter. We know that the wavelength is defined as distance covered by compression and adjacent rarefaction. If you draw a wave, this is the compression and this is the rarefaction. So the distance covered by one compression and one rarefaction is wavelength lambda. So wavelength lambda in this case is 68 centimeter, but it has to be represented in meters. So it becomes 68 by 100 which is 0.68 meters. Therefore, lambda is equal to 0.68 meters. Now we will go to the part C. What does it say? Velocity of the sound wave. We know from the wave equation, velocity v is equal to f into lambda. And we know f, we know lambda, so we can find the velocity. So f in this case is 500 and lambda is 0.68. So on multiplication, we get it as 340 meters per second. Therefore, v is equal to 340 meters per second.